Examiner only test your knowledge of understanding in the topic known as electrolysis. They are not going to they won't start by asking you some irrelevant questions. Rather, they will ask you some things to ascertain if you understood this topic called electrolysis. Now, one of the problems students normally have in chemistry for any of the exams, call it WAEC, call it JAMB, or any external exam is that whenever they are giving questions in electrolysis, they seem not to understand, like they may not be able to follow the instruction or do exactly what the examiner wants. Now, in this video, I'm going to break down everything about electrolysis. I am going to calmly explain them. I'm going to point out things that you need to know so that anyhow your examiner asks you the question, you can answer the question. You see, it's only when you understand this very well, that is when you can be able to answer the question or do exactly what your examiner wants. If you are new to this channel, don't forget to subscribe. Now, without wasting much of your time, let's get started. All right, before I start now, please, I would like you to do something now. I would like you to, first of all, put on your earphone or earpiece or earpod, anyone, so that you can listen to this video clearly. And also, make sure you watch this video to the end so that you will grab every bit of information that I'll be passing. Please, I'll be pointing out key things that you need to know in this topic. I am not here to teach you this topic as a regular topic, whereby what is electrolysis, we'll just define it as a regular way you were taught back then in your schools. I am not here to do that now, but I'm here to break it down and point out things that you're supposed to know so that any question that comes up, you can be able to answer them. So let's get started. Okay. Now, first of all, what is electrolysis? Let's start from definition that you already know. Let me start from what you already know. Now, you know already, or maybe if you don't know, let me still define it if you're not sure of the definition. Electrolysis is the chemical decomposition of a compound. Of a compound, chemical decomposition of a compound brought by passing what now? Direct current, brought by passing direct current in molten or solution form of the compound. That is what we call electrolysis. Now, in actual sense now, the key thing that you need to take note, or I will be pointing out in this video is, first of all, let's look at what we call chemical decomposition. I'll comment on what we call chemical decomposition. Then later, I'll also comment on what you call the compound. But before, let me start from the word compound. Now, that compound they are talking about in this topic, the compound they are talking about, is referred as what you call electrolytes. It is referred to as what you call electrolytes. I'm going to explain or define what electrolyte is all about. But before then, you should bear it in mind that the compound in this electrolysis that we're talking about is what you call an electrolyte. And they said that this process cannot be complete or is not possible if we don't have what? It must be in the presence of, we must have direct current, which means that we are going to pass what we call direct current. Alternating currents cannot do this now. Then here is where I want us to point out chemical decomposition. Decomposition. This is one of the challenges students normally have. They don't understand this chemical decomposition. And if you do not understand chemical decomposition, you automatically may not be able to create those equations, half-cell reactions, whether the anodic half-cell reaction, cathodic half-cell reaction. If you do not understand it, you may not be able to know the byproducts that comes out after the electrolysis. So first of all, you need to understand what is chemical decomposition. But what does it mean? That word chemical decomposition is very simple. Please listen carefully. If I'm saying this now, please bring out your pen, bring out your paper, and write out this now. What exactly is chemical decomposition? Chemical decomposition just simply means what now? Just to ionize that compound. It just simply means ionization of the compound. And please, when I say chemical decomposition, or when I say chemical decomposition, now, what do I mean by chemical decomposition? It just simply means now for you to dissociate or for you to break that compound into its ion. Now, look at this now. We have a compound. You know, they say that this reaction must occur where now? It must be a compound. And that compound must be in what state now? Molten or solution form. I'm still coming back to this. But first of all, they mention the word compound. And you must remember that that word compound contains two things. Whenever you hear the word compound always consists of two things. And what are the two things that a compound consists of? Compound consists of what we call a cation, and what we call what now? An anion. Please, these are just words. Please, what do I mean by a cation? Cations are those ions that are positively charged. Those ions that are positively charged are known as the cation, whereas the anions are those of them that are negatively charged. So those of them that has a negative charge are known as anion. It is actually known as, it is either you call it cation or you call it cathode ion. Why do they call it cathode ion? Because these ions which are positively charged will go to the cathode, and cathode is always negatively charged. Sorry, it's always negative. All right. So now, how about this anode? This one is, how about this anion? This anion is also called anode ion. And this anode ion, why it is called anode ion is that this ion, which is negatively charged, go to the positive electrode. This, remember, let me say that again. Let me repeat that again. I said that the positive ion goes to what electrode now? To the negative electrode. Whereas this negative ion goes to the where? To the positive electrode. So, and the positive electrode is called anode, and the negative electrode is called cathode. So, because of those ions that move to those electrode, we call them cathode ion or cation, or we call them anode ion or anion. I hope you are getting all this in there. Please take note of all this. Now, the next thing I'm going to talk about is, since I've already known that this consists of what we call cation and anion, so how do I break compound down? I mean, how do I break, or how do I set, or how do I make a compound to become an ion? Sorry, if I mean by that, now I meant that how do I convert, or how do I make a compound to become an ion? It's very simple. Now, the first thing that I need to make you understand is, some of you, or this might be your first time of doing so, but I will tell you exactly what to do when it comes to that. Now, this is what you're going to do. So this is what you will do. First, you need to know about, the major thing that you need to know about is what we call the anions, these anions. You need to know about them. You don't have a problem with that because these compounds, they are in form of binary. They are binary compounds. Now, binary compound in the sense that I meant that they basically contain two things, which is a cation and anion. And the anion is always a challenge. The one that seems to be confusing to students, these radicals, these ones that are here that I call the radicals, all these radicals are always problem. If not, others are very simple. And let me show you how to break compound now. Now, let's take, for instance, that one of these ion combined with this. Okay, let's say one of these now combined with, let's start with one of these that's combined with, let's say, this and this. That is the halogens now. We have something like, I have something like sodium and sodium chloride. Now, this is a compound. And this compound, I'm expected to decompose or break this compound into its ion. What will I say? Now, what I will just say is, I will just say sodium and I'll say chloride. Now, remember, the first one is always positive. The second one is always what? Negative. And because I did not see any number below it, I can just leave it this way. How about if I have something like this now, MgL2, for instance now. For instance now, okay, let me just use another one. Let me use bromide, something like this now, and I have something like this, and I'm expected to break it now. If I am to break it now, what will I say now? Normally I will say M and I will say Br. Now, what I'm going to do next is, you see this number below here, we now go on top here. So I'm going to have it as a plus 2. Then what number am I having here now? 1, invisible 1. So it's going to be on top here as minus. And even if you check it out, you see that bromine or your bromide ion is always Br minus. And that is how the bromide ion is being written. Now, what if it comes like this? Now I have H2SO4. Now this one has what you call the radicals. Okay, let's say it has radicals. Let me put it up here. Assuming it has radicals. If it has radicals, how am I going to do that now? First of all, be careful. Be careful with these radicals. You see this SO4, SO3, and CO3, and OH. If you see them written like this without being in parentheses or in brackets, so what it means is that the number beside them, the total number beside all the whole radical is what? Is 1. So that is what you're going to take note of. So what I'm going to do now is, I'm seeing SO4. Since I am not seeing any brackets here, I'll just break this in down and say H, and I'll say SO4. These two here will now go on top of here. I'll say 2 minus. Then because I did not see any brackets, be careful. What did I say? If you did not see any brackets, what will I do now? Okay, since I did not see any brackets here and I'm having 2 here, so I will assume that what I have here is what? 1. I'll just say plus 1. But be careful with this case. What if the case is like this? What if we have something like CuSO4 and I am expected to break this into its ion? Into its ion. How can I break this compound into its ion? Very simple. The same thing. What you're going to say is CuSO4. In actual sense, what am I going to say? Yes, I told you here, all brackets go to be 1. I know you might be expecting me to write 1 here. I'm expecting me to write 1 here. Well, I'm not going to write 1. This case is different. And why is it different? Because actually copper has a plus 2. It's always plus 2. And this one has 2 minus. It's just that the only reason why you're not seeing the number, this is 2 supposed to be here, 2 supposed to be here, all in bracket. The only reason why you are not seeing that 2 that's supposed to be below here and this 2 that's supposed to be in all brackets is because it was cancelled out when we wanted to write them. So because it was cancelled out, we cannot see that 2 any longer. So what it means is that if I am to break it into its ion, what will I do now? I'll also include its ion. But majorly, someone might be asking, this is very confusing. How will I know which one or what to do? If I am to advise you exactly what to do so that you will not get confused, please take note of this now. The only thing I need you to do is take note of this anion. Please study this anion very well. Study it very well alongside with its charges. If you're able to learn this anion very well, especially the radicals, we don't have problem with the halides. We don't have problem with the those ones of them in the halogen family, which are those ones that I marked now. The only one you're going to have problem is what? The radicals. So study this very, very well. Now, why did I say you should study it very well? Now, let me tell you why I say you should study it very well. If you're able to study it very well, you have to know the charges that it ought to carry or bear. If you are saying something else, you know exactly what it means. Now, how do I mean now? Now, let's say I have something like, I have another radical that I didn't even include. Let's say I didn't include this one. Let me include it now. NO3. Okay, let's just say I have something like Cu. Let's say I have something like a CuCO3. CuCO3 like this. I have CuCO3. Or let's give another example because I've made use of this C a lot. Now let me use another example. Let's say I have something like ZnCO3. And this ZnCO3, I am expected to break it into its ion. What will I do? Now, what I will do is, I told you to study these anions very well. And if you are aware of this anion, what you're going to do is, you just say Zn, you say CO3. Now, since you are not having a number here, you are not having any number for something like this, especially radicals, no bracket, no number. What else did you remember? You now remember that CO3 is 2 minus. You now write 2 minus. And automatically, if I have 2 minus here, here is going to be what now? 2 plus. This case only occurs whenever you observe that there is no number below here and there is no number in bracket. This is not in brackets. So this is when something like this happens. Aside this now, every other thing remains the same. Please, what do I mean by that now? Assuming you have something like ALCL3, ALCL3 for this kind of issue, you see that I have number already. I have aluminum and I have 3 here. I have number here. Compare with this one that I have here. Compare with this one. This is a radical. It's supposed to be all brackets, but since it's not in brackets, I will assume that what number I have here is going to be what? I mean, the number I have beside here is going to be what? Is going to be 1. And since it is 1 here and it is also 1 here, just break them into its ion, zinc and carbonate ion. Then remember, what did I say you should remember? Remember that carbonate has a charge of what? 2 minus. You write 2 minus over here. And since you've written 2 minus here, what will you write here? Now you write 2 plus here. This is only for this case. What case did I say you should? What case is that? I said a case of radicals having no number. There's no number here and there's no number here. I mean, there's no number like 2, 3, 4. Rather, the only number you're seeing here is 1 and 1. Assuming this radical is not in brackets, because assuming it is in bracket and you have number beside it, that's where you now go with this principle. And what principle am I talking about here? This principle says you will now take this number on top. You take it on top, which is AL3 plus. Then this one, you take the number here on top of here. It's going to be CL minus. And that is what that principle said. So now let's take let me give you another example now. Assuming I have something like what else should I give you now? Okay, let's say I have something like CuNO3 all brackets 2. Nice. This is a very good example. CuNO3 all bracket 2. And I looked at this now, this compound, and I want to break it into its ion. What will I do to break it into ion now? Now, please pay attention because this is the major part of it all. If you're able to know how to break or decompose compound, you've known or you've learned this topic very well. All right. Now, how can I break it into its compound now? Now, the only thing I'm going to do is, what principle will I do now? This is actually a radical. Like I told you before, it's actually a radical. And how do I know it's a radical? It contains 2 elements with a single charge. So this is a radical. But this radical, it is not like this one that is not in brackets. You see that the NO3 is all in brackets a number. This one is not in brackets. So since this one is all in brackets a number, I will apply the principle that I used here. And what did I use here? What I did here was that I took this number below here, I took it on top here, and I took number below and I took it on top here. So that is why I'm having AL3. And remember, I told you that the first element is going to be positive, and the second element is going to be what? Negative. So since I am not having 1, 1 here as usual, what will I do now? I'll go by this method, which says, I will say Cu, this number will come on top. I will say 2 plus. Then I will now write NO3. This, what number am I having here? 1. I will write minus. So that is exactly how to break what? How to decompose or break compounds or change your compound into its ion. That is, break it down into its ion. That is exactly how to do that now. Since you've understood this one now let's go over to the main thing that we're going to talk about now, and which is what you call what now? Let's talk about what you call electrolytes. Let's talk about what you call the electrolytes. Now, before I talk about or explain what electrolyte is all about, and let me point out one thing. I told you that this chemical decomposition of a compound, and what compound? The compound must be in either a molten form or a solution form. Now, I told you that this compound is usually, they are usually what you call electrolyte now. So when the compound is in the molten form, the charge carrier will become what? Will become ion. So please take note of this. Write this in out. Write this in down. I said when the compound, and the compound we are talking about is what? That compound is basically what you call your electrolytes. So when the compound is in molten form, charge carrier, its charge carrier will be what now? Okay, molten form. Current charge carrier. Okay, let's put it this way. Molten states. Okay, let me put it this way. Molten state. Current charge. Sorry. Current carrier. Sorry, why am I even writing charge? Current carrier. Current carrier is what? Is ion. So whenever this compound that we are mentioning or we are talking about is in molten states, current carrier will become what now? It's going to be what now? It's going to be ion. It's called ion. But when this compound, please take note of this, it's very important. When the compound, which is the same electrolyte that we're talking about, is in solution form, is in solution state. So, current carrier, the only thing that will make current to flow in that electrolyte, that's what I mean by current carrier, flow of charge. The only thing that will make current to flow in the whole electrolytic cell from the electrolyte to the electrode to the external load and back to the electrolyte. So the current carrier is going to be what? Current carrier is going to be what? Is what you call it now? Hydrated ion. Hydrated what? Hydrated what? Ion. Now remember that this word I said solution can also be called aqueous state. So it's either use solution state or I can say aqueous state. The actual word I'm supposed to use here is aqueous state. So it means that in aqueous state, it means that this compound was added in water, like you added water to it to form a solution. Or like the other one that is in molten, unlike the other one that is molten that has little or no water in it, especially little water in it. But this one, the compound is dissolved in water. So that is what we have now. So bear it in mind. What did I say now? I said that when the compound or when the electrolyte is in a molten state, what exactly will carry current in the whole electrolytic cell or in the whole cell? It's going to be what? The current carrier is going to be ion. But if the compound is in aqueous state, what is going to carry the current now? Hydrated what? Ion. Since it's in that state now, it's going to be hydrated ion. Now, the next thing I'm going to talk about is what we call the electrolytes and the non-electrolytes. And we're going to see that and know the difference between electrolytes and what we call now the non-electrolytes. Now, let's start. Electrolytes are compounds that conduct electricity in what? In molten or solution what? Form and decompose. They also decompose. So we say that electrolytes are compounds that does what now? Okay, that does what? They conduct that conduct what? Okay, electrolytes are compound that conducts electricity in molten or what? Or solution what? Form. And they also do what? They decompose. We've already talked about this decomposition. They also decompose. It's either you call it decompose or you call it dissociate, like dissociates. Yes, you can also call it that way. Dissociates. Or it just simply means that you have to turn it into what? Into ions. Converting that compound into what you call ions. That is exactly what we mean by that. Now, this compound that they say that it conducts electricity. Now, let me ask you one question. What is the question that I'm going to ask you now? Now, conduction of electricity, if the electrolyte, conduction of electricity in molten state, that is, if the electrolyte is in molten state, conduction of its electricity is by the means of what? What did I tell you? Ion. Conduction of electricity, take note of what I'm saying. I just said that conduction of electricity of electrolyte in molten state is by the means of what? Ions. How about conduction of electricity of electrolyte in solution form is by the means of what? Hydrated ions. Take note of that. I said that in my previous, just few lessons ago. That's when I said it. So just bear this in mind. Like I told you before, I am not saying teaching this as a regular teacher. I am pointing out things you need to know. If you're able to know all these things now, you can answer any question your examiner presents to you. So let's see that now. Now, this electrolyte now, what are the examples of electrolyte now? Electrolytes can be gotten from what you call what now, from your mineral acids or your mineral acid. I'm going to break it down fully later. Then 2, you can get it from what you call your alkalis. And 3, you can also get it can also be gotten from what you call the soluble ionic salt. So these are these are the 3 things that can easily give us what we call our electrolytes. They can give us our electrolytes. Then the next one we're going to talk about is what we call the non-electrolytes. What are the non-electrolytes? The non-electrolytes, okay, let's say the non-electrolytes, okay, are compounds that do not conduct electricity. Those compounds that do not conduct electricity in either molten or solution form, So they are what? Compounds. Okay, let me put it here. They are compounds, okay, compounds that do not conduct what? Okay, conduct what? Electricity. Okay, electricity in either what? Molten or solution what? States or form. So it's in either molten or solution states, they don't conduct electricity. And those ones are known as what you call what now? The non-electrolytes. Now, the examples of non-electrolytes are we have covalent solids. Covalent what? Solids. And the covalent solids that we're talking about are such as what you call your sugars. We have such as your sugars, and the sugars we are talking about is what you call the sucrose, and the galactose, and the glucose. Then we also have paraffin wax. Those covalent solids. We also have paraffin wax, paraffin wax. I hope you are taking down all this information. Please, I hope you are writing them down. It's very important you write them down. Now, how about the liquid part of it now? We have liquids such as what? Kerosene. Okay. So we have such as kerosene. We have petrol. Okay. We also have alcohol. All these are known as non-electrolytes. So if you are giving a question tomorrow or anytime now, and you look at the question and they say, which of these are non-electrolytes? Now just scan through it now. Just identify what are you going to identify. If you see your sugar, either they call it sucrose or they call it glucose, they're also in the family of sugar. Paraffin wax, okay, then kerosene, you have your petrol, and you have your alcohol. All these are examples of what we call the non-electrolytes. They can't conduct electricity in either molten or solution form. So, but the ones that can conduct electricity, I've already talked about it now. Okay, now I'm going to break down that electrolyte now very well now, because under electrolyte now, we have 3 classes of them. Now we have what you call the strong electrolytes. Sorry, we have 2 classes of them. We have what you call the strong electrolytes. We also have what you call the weak electrolyte. Just 2 of it that we have. So let's look at them. Talk about what you call the types of electrolyte that we have. We have what you call the strong electrolytes, and we have what you call the weak electrolytes. So we have what you call the strong electrolytes. We have the strong electrolytes. We have the strong electrolytes. That's the first one. And the second one, we have the weak electrolytes. For the strong electrolytes now, these are compounds that ionize completely in water. So those compounds that ionize completely in water is what you call what now? The strong electrolyte now. So strong electrolytes are compounds. Remember, I always say that this compound we're talking about are always your electrolytes. I mentioned that at the beginning of this class. Now, compounds that does what? That ionizes completely in water is what we call the strong electrolytes. And basically, they have three classes. And what are they now? First of all, examples of our strong electrolytes are gotten from where? The examples of our strong electrolytes are: one, we have what we call the mineral acids. I've given that as an example of electrolyte that we have. So we have our mineral acids. So we have our, not mineral acid, I mean strong mineral acid. So let me put the word here. It's going to be strong mineral acid, not mineral acid, because we have so many mineral acids. So the strong mineral acid that we have are only three. Please take note of this that I'm saying and listen carefully. Pay attention. I said that the strong mineral acid that we have are only three in nature. There are only three. And which are, they are HNO3, HCl, and what we call it now, H2SO4. These are only the only mineral acid that we have, the strong mineral acid that we have. So whenever you look at the question and you are asked which of the following is an electrolyte, check if you are going to see acid, and what acid are you going to check out for. If you are seeing your strong mineral acid, these are examples of what you call electrolytes. Then another one is what you call the strong alkalis. We have another one as your strong alkalis. And the strong alkalis that we have are only two in nature. There are only two. And what are the two strong alkalis that we have? They are just potassium hydroxide and what? Sodium hydroxide. They are only two. They are not more than two. So how many electrolytes have I mentioned to you now? They are already 5 in numbers. So examples now, just bear it in mind that they are just 5 in number. They are more than 5. I'm still going to list the last phase. Okay. So these are HNO3, HCl, H2SO4, KOH, and sodium hydroxide are examples of what we call our electrolytes. Then another one is what we call our, let's remove this here. Then another one is what we call it now, soluble ionic salts. Another one is soluble ionic what? Salts. Soluble ionic salts are another category of strong electrolytes that we have. These are the ones that will give you what we call strong electrolytes. Now, the soluble ionic salts are, the question now is, how can you know the ones that are soluble ionic salts? Don't worry, I'm going to let you know that in this video. Now, the ones that are soluble ionic salt is, whenever you read that question or you look at that question and you now discover that the compound or the options they gave to you, compounds they give to you in the option, that some of them has what you call potassium, sodium, and calcium in it. So whenever they have something like potassium, sodium, and ammonium, if they have these three now, so salt that contain, first of all, how do we know that this is a soluble now? It's all about salts that contain what? What did they contain now? Assume they contain, you see something like potassium, and you saw something like sodium, and you saw something like ammonium. Those salts, when I say salt, I didn't mean the hydroxide too, because when I look at that now, I'm not talking about this, because don't be careful. I'm not expecting you to say ammonium hydroxide is a strong, no, I'm not talking about this, because automatically when you saw this hydroxide, whenever you see this hydroxide this way, it's no longer about salt already, where this is no longer a salt. So, salt does not contain hydroxide. It's all about acids always contain hydrogen. Base always contain hydroxide. This is how I mean. Look at acid. They always start with hydrogen. But for alkalis or hydroxide, they always end with OH, hydroxide, OH. So, but when it comes to salt doesn't end with that. Let's say, for instance, this is a salt, potassium chloride. You are not seeing something like hydroxide in it. It is true that it's possible for you to have what you call acid salt or basic salt. Yes, we can have it. But major thing there is this. Even though you are going to have hydrogen or you're going to have hydroxide in it, it must end with one of these chloride, sulfate, no, one of these that are not OH or hydrogen. This is how I mean. You can have something like this. This is KHSO4. Okay, this is a salt. And why did I call it a salt? I also call it a salt. Actually, hydrogen is in it, but the hydrogen is not starting it. Even if hydroxide is in it, hydroxide must not end it. If hydroxide ends it, it's no longer the family of salt. You can start classify them under base or whatever. So please bear that in mind, so that you will not say that I said that ammonium hydroxide is an example of, no, it's an example of a strong electrolyte. No, I did not say so. So take note of that. Okay, now let's continue with the salt that we're talking about now. Soluble ionic salt. I say that salt that contain potassium, sodium, ammonium. So maybe something like ammonium sulfate this way. Sorry, yes, ammonium sulfate. Okay, ammonium sulfate. Let's put 2 here. Okay, something like ammonium sulfate is an example of what you call soluble ionic salts. Now, what are other examples? Other examples are, but before I go over to that example now, look at this. Assume you have something like CH3COONA, something like this. You see that this compound that I have here now, this compound contains what you call sodium. So it's still under what you call the soluble ionic salt. So automatically you will just say that this compound is an example of what you call electrolyte. Take note of that. So how do I know an electrolyte? It must contain, if it contains potassium, it's an electrolyte. Sodium, it is also an electrolyte. Ammonium, it's also what? An electrolyte. I mean ammonium salt, or not ammonium hydroxide. Now, another category that will also help you out is what you call salt that contains, we have salts that contain, any salt that contain what you call NO3. If the salt contain NO3, if you look at the compound and you discover that the compound contains NO3, like something like KNO3, this is also an example of an electrolyte. Maybe something like MgNO3, all bracket 2. This is an example of what you call an electrolyte. Now, another example, another category is what you call salts that contain chlorides. Salts that contain what you call what now? Chloride. I gave one example here already. So anyone that contains sodium chloride, magnesium chloride, aluminum chloride, anything that contains chloride, it's an example of what you call strong electrolytes. Then the last phase of it is this: salts that contain sulfates. Salts that contain SO4, sulfates, salt that contains sulfates. And the sulfate that we're talking about is sulfate. We are talking about excluding the ones of lead sulfates, silver sulfates, and what you call mercury sulfates. So these sulfates that are listed out are not part of it. They are not part of it, but other form of sulfate are part of what you call our electrolytes. Now, I would like you to play this video again. Maybe if you do not get all this now, play it. You can also reduce the speed. If the speed is maybe normal, you can reduce it to -1, so that you see if you can capture all these things again. All these things that I say, please take them down. Take note of this, because they are going to help you. So let's go over to what you call the weak acids. Sorry, the weak electrolyte. Let's talk about what you call the weak electrolyte. How about the weak electrolytes? Remember, strong electrolytes are gotten from your mineral acid, and the mineral acid that I say that we can get them are: 1, your HCl, your H2SO4, and your HNO3. Please recite with me. It's going to help you. Then the next one, I say that where you're going to get your strong electrolyte is what? Your strong alkalis, which are your potassium hydroxide and your what? Sodium hydroxide. Then I also told you that another group of another ones that will give you strong electrolytes are what you call the soluble ionic salts, and which are the salts of what? Potassium, sodium, and ammonium. Then I also said that salts of what again now did I mention? I also told you that salt that contain triosonate-5NO3. Any salt that you see or any compound that you see that contains NO3 is an example of what you call an electrolyte. Then I also say that any salt or any compound that contains chloride is an example of what you call strong electrolyte. But if you're talking about chloride now, you're going to exclude the one of lead, silver, and what again? And mercury. Then the last one is what? The salt that contains sulfate. I don't know whether I mentioned this, but for sulfate, SO4, for sulfate, or any salt that contains sulfate, SO4, excluding the following, excluding lead, barium, and what you call it now, calcium. So these ones are excluded. They are excluded in it. They are not soluble, so they are excluded. So we can't include that as an example of what you call electrolytes. So it means that if I have something like magnesium sulfate, assuming I'm given an option and I'm asked to find out or identify or I am asked a question like, which of the following is an example of electrolytes or strong electrolytes? Automatically, and I saw magnesium sulfate. Can I also select that? Yes, I can select that. I hope you are taking down all these points, because it's only when you take down these points, that's when you can answer any question your examiner asks you very, very well. It's only when you understand this. See, these topics are very, very simple. These things are very simple. The only problem we have is this now. You may not understand it this level. Probably you might have read it, or probably someone might have taught you this topic, but maybe you do not understand it to this level. So that is why when they bring up question or any question, you start guessing. You don't need to guess. If you are able to get all this information that I'm all stating clearly in this video, you can solve any question yourself, and you'll be sure of what you wrote and not guesswork. Okay, now let's talk about what you call. Let me talk about what we call the weak electrolytes. Now, the weak electrolytes are, we have the weak electrolytes. The weak electrolytes. Now, what are the weak electrolytes now? Now, these ones, they ionize partially in water. They dissociate partially in water. So these are compound. They are what? They are compounds. They are compounds that does what now? That slightly what? Dissociates. Okay, dissociates or decompose. You can use the word decompose there in water. So, and the examples of them are examples. We have example as the weak base. Now, weak acid. Any acid that you see aside HNO3, H2SO4, and HCl, any acid that you see apart from these three that I mentioned now are under what you call the weak acid. Simple. Now, let me give an example. I have something like CH3COOH. This is a weak acid. This is a weak acid. In as much as it has H at the end, it's a weak acid. The another example is what you call H2CO3, even though it started with hydrogen. Yes, hydrogen showing that it's an acid, but it's a weak acid. How about something like H2SO3? This is also a weak acid. How about any of them? Any example? H3PO4. How about that? Maybe I think H3PO4, also a weak acid. All this is an example of weak acid. Now, since this weak acid will form what you call, remember, they will form what you call, they'll give you what you call the weak electrolytes. Now, another example is what you call the weak bases. The weak bases. Now, the weak bases, we have, what are the weak bases that we have? We have aqueous ammonia. Now, aqueous ammonia. Aqueous what? Ammonia. And aqueous ammonia is something that I pointed out when I was mentioning something about strong electrolytes. So this is aqueous ammonia. Ammonium hydroxide is called aqueous ammonia. So you see that. So when I was talking about compounds that will give you strong electrolytes, I told you that the compounds of ammonium will give you that. But if you're talking about a compound, please exclude the one that has OH. It's not a salt. This is not a salt. It's not under the family of salt. See where I classified it. I classified it under what you call base. Remember, I told you that base will always end with OH. So if you see something like OH, it's like OH is under what you call base. But if you see hydrogen starting, it's going to be what you call acid. Basically, it's always, this is the way they are. Except there are some few exceptions, something like ethanoic acid. This ethanoic acid that is like this, just a few exceptions. So I've given an example. Then another one is what you call the lime water. Lime water. Lime water is also an example, of what you call the weak bases now. Okay, now since we've talked about it now, let's talk about what you call the conductance. You remember, this electrolyte now, what are they doing now? They conduct electricity. They conduct electricity either by the means of ions for melting or by the means of hydrated ion for aqueous solution. They conduct. But let's see the level of conductivity. So let's talk about the conductance of electrolytes. So that's the next thing I'm going to point out. Now somebody might be wondering, do we actually need conductivity of electrolytes? Yes, they might give you different electrolytes from different classes, probably the non-electrolytes, a weak electrolyte, and strong electrolyte, and you might be asked to arrange it in the order of increasing conductivity. You are expected to do that yourself. So that's why we need to see something like that, because it sometimes occur or appear in your exam. Remember, I told you that this video is all about breaking down things you need to know about this electrolysis, so that by the time you move into the hall, any question your examiner asks you, you can be able to answer them. But that's why I'm breaking them down to this level, so that you pick every information that you need to know.